Hello guys, welcome to Blink and Build. So I was working on a project the night before a presentation and I asked AI tool to generate a circuit diagram for me, and this is what I got. You can see here ground, input, output, VCC, everything connected to 5 volt, 3.3 volt. It's looking good, but its circuit is very messy. You can't tell which circuit it has been connected to which pin. Like if you present this at your presentation, then you are screwed up. Every single wire is connected to the wrong pin. I spent 2 hours fixing something that should have taken 5 minutes. And the worst part, every free tool out here only supports specific microcontrollers. If your sensor or module isn't there in their library, you're stuck. So I built SchemFlow, and that's what we are covering today. Now I will show you exactly how to use SchemFlow, a free browser-based wiring tool I built to fix this exact problem. No login, no sign up, no install. Just open the link in your browser and you are live. Link of the app is in the description. Let's get into it. Before we start wiring, here is the one thing you need to understand about the SchemFlow works. The tool is a wiring layer. You bring the image of your components and then you draw wire connections directly on the top of it. So it doesn't matter if you are using an ESP32, a custom sensor, a random breakout board. If you have an image of it, SchemFlow works with it. No library limits. The first step is getting your component arrangement ready as a single image. Let me show how you can do it. Now let me show you how to use the Canva for this. Open Canva and here you should select the whiteboard. It will take some time. Once you selected it, go to uploads and upload files, and here you can upload all the images. Just upload the images. It will take some time to upload. After upload, bring every image to the main this one. Now 1, 2, 3, 4, 5, 6. Yeah. Now here you can see you can arrange each and every component as per your requirements. Now let me arrange the main board. I will turn it into 90-degree. Yeah, now it's fine. Now let me increase the size of this. Yeah, now it's looking fine. Now OLED, let me decrease the size. Yeah, I think this is fine. Now the buzzer. Uh, okay, I will place the buzzer this side, so it will be looking fine. And this DTH22 also will keep here left side itself, so it will look fine. And I hope it's looking fine. And OLED and the joystick, let me increase the size of this so it will look little bit good. Yeah, now it is looking fine. This also I will increase, and let me rotate it little bit so it will correctly be horizontal. Yeah, now you can see this arrangement is looking good. Let me increase this somewhat. Mm, and increase this also little bit. Yeah, now you can see it is looking very good. Now you select this. Now right click on this, download selection. PNG, okay, fine. Let it download. It will take some while. Yeah, it's getting download. Once you download, you can import schematic and you can select the image. Yeah, this is what we required. I will click escape. See, the complete image is here, and now it's the turn for wiring. Yeah, now let me explain you how to draw wire here. Now the left side here is the import schematic. Here I did import schematic and imported the image. The maximum file size is 50 MB. Here you can select wire or eraser. Here view and scale, it will change accordingly. You can increase or decrease here accordingly. Next, here comes the direct and PCB. This one PCB one looks professional. It will be like this, as you see, 90-90 degree. You can click escape to go back, and the direct wire is like this. You can directly join anything. It will be used to draw some extra components or extra battery, those things here. And rendering style, it is like smooth and rigid. For example, now you can see it is smooth. If you click rigid, it will be rigid. It depends on your preference. Whatever you want to select, you can select. I will do Control Z, so it will be deleted. And here comes the default wire colors. These are the default color palettes which are available. If you don't want this, you can click here and you can select anything manual. This is the thickness of the wire. Now you can see the current thickness is this. So if you want to increase according to the board, I will keep 8 and I will test. Yeah, this one looks good, but it is too much thickness, so come back to 7. And this one seems to be okay, so I will keep 7 for drawing here. Here you can see the total wires, how many wires you will be using, and export schematic. After completing, you can export the schematic. Now let me start wiring the circuit. Yeah, now let me start wiring. Let me show you how to do it actually. Now coming to MQ135 sensor. Now I will first start wiring with this sensor. So there are 4 pins, but the pins we are using is A out, GND and VCC. VCC will be connected to 5 volt. Since I have selected the pixel here, you find 5 out, 5 volt, and you can single click here. Wait, it should be PCB, so it will be looking good. Click, then come to 5 volt and double click. Yeah, the first thing is wired. The second one, ground, select black. Then in the same procedure, you can click here, double click. Yeah, ground part has been done. Wait a minute, I messed up. This is VCC. It will go to 5 volt. Double click. Next, ground, single click. Now double click. Yeah, now A out, let me choose different color. Let me select yellow, and A out will be going to A naught according to the code. So I will click here and I will make it to A naught. Yeah, now the gas sensor part has been done. Now moving to the DHT22 sensor. Here VCC, you can give it to 3.3 or 5 volt. Let me give it to 5 volt now. Select red. Now I will be giving it to 3.3. Yeah, now ground to ground. Let me coincide with the same pin. Yeah, ground to ground, and data pin to D2. So it's that side. Okay, now let me select a blue color this time, and I will be coming from this side, and finally done. Now the sensor has been done. Now moving to the buzzer. This is an passive buzzer, so you need to input for VCC, ground and I note. So what I will be doing is, yeah, ground. I will first ground the pin. I can see ground this side, so I will give ground here. Next in IO, it will be going to pin 8. This time I will select orange. IO will be going to pin 8. I will go from bottom, double click. Yeah, done. Now VCC I'll be giving to 5 volt itself. I can also wire on the board. I will give this VCC to this 5 volt. Yeah, it has been done. Now moving to the built-in LEDs, like in this code there were built-in LEDs, it will automatically turn on, no issue. Now OLED display part, VCC will be 3.3 volt, ground will be ground. Where is 3.3? Yeah, I got it. Yeah, VCC 3.3 volt. Let me take one turn here. Yeah, now ground will be ground. Go to black, select. I will better give to this ground. Yeah. Now SDA and SCL. There are SDA and SCL pin here. You should give to the same pin. CL. I will choose green and blue. It is SCL and SCL is here. Yeah. Now SDA. Yeah, it has been done. Now the final part is joystick module. Here there is ground, 5 volt, VRX, VRY switch. So this will be going to 3.3 volt. Okay. Yeah, the 3.3 volt pin is here. So I will give it to here. Now let me select red. 3.3, ground, black. Any ground you can give. Next, wait. The first one is ground. The second one is VCC, means 5 volt. VRX, it is A1. Okay. A1, I will be using the new color. Let me choose purple. Yeah, purple is there. VRX, it is A1. Yeah, it has been selected to A1. And VRY, I will use pink. Yeah, it also has been done. Now SW. SW will go to digital pin 3. Okay, for this better I will use gray. Yeah, wait, I will go from back side, it will be looking good. Pin 3. Yeah, now you can see the complete circuit diagram has been done. These three wires I just for time being I kept inside the controller, but if you have some space outside you can come from outside, so it will be looking very good. For this microcontroller there are inside pins, so this problem had happened, or else everything would be come from outside, so it will be amazing. Now I will show you the smooth and rigid part. The smooth, since we have smooth, the curve and all are smooth, it will look good, but for professionalism better to go for rigid. So here every 90 degree it is like proper 90-degree turn, so it will be looking good in like paper, if you're publishing paper or college presentation. For these things you can select this part. And finally the export image. Once you done export image it will be saved, and once you saved you can open the image, and this is the image, and you can see clearly there is no reduction in the image quality. You will get the same image quality as uploaded with the wire layer as extra layer. So thank you so much for watching, and you can freely use the tool, and it's open source, you can run locally or anything however you want. Thank you for watching guys, have a nice day.